Hi, ArcfieldWeather.com meteorologist Paul Dorian here. We're approaching the end of the month of December here in 2021, right into the heart of the winter season of 2021-2022. And I know a lot of the viewers are very interested in computer forecast model generated snowfall maps, as am I. You see them all the time on Twitter or Facebook, and I wanted to put out this video just to put out a warning that you have to be very careful of computer forecast model snowfall maps, especially if you're going far out in time, let's say for the next 10 days out beyond the current time period, and specifically for particular computer forecast model runs at 6Z and 18Z. Computer forecast models are typically run every 6 hours at 12Z, 18Z, 0Z, and then again at 6Z. And the upper air observations are critical that are fed into the initialization of these computer forecast model, and there are big differences between the 12Z, 0Z runs and the 6Z and 18Z runs. Specifically, upper air observations are collected around the world at 2 times a day, 12 hours apart on average. 12Z or 0Z, or you could call that 1200 hours GMT or 0 hours GMT. And the radiation data that are launched at these particular upper air observation sites provide the data that actually in turn are fed into the computer forecast models, and the 0Z and the 12Z model runs will feature the most current upper air data. However, the 6Z and 18Z model runs will actually have stale upper air data that is 6 hours old fed in as initialization data. And when you're talking longer range snowfall maps, the upper air observations are critical. Anybody who's watched videos that I've put out over the past several winters know that I always harp on the fact that many ingredients have to come together for snowstorm, for example, in the mid-Atlantic region, and those important factors are really dictated by what goes on in the upper atmosphere. So the upper air data that fed into these models are critical for such things as snowfall maps, especially out 5, 10, 15 days in advance. And you really have to be wary if you're looking at a snowfall map at 6Z, from the 6Z model run or the 18Z model run. The way I deal with it as a forecaster, if I see a big change in snowfall amounts for, let's say, 10 days out with a 6Z model run, I'll wait till the 12Z model run to see if there's confirmation of that signal. Now let's take a look at a map of the U.S. upper air observation sites. These are where radiation balloons are launched. The radiation balloons are launched at these particular sites. They have instrumentation that will measure temperature, humidity, and pressure from the ground level all the way up to the upper part of the atmosphere. Typically they'll go up over maybe a 30 to 60 minute time period, up to maybe 100,000 feet or so, and then they'll burst. But all the while, from the ground level to the upper part of the atmosphere, they will record temperatures, humidity, and pressures. And all that data is then ultimately fed into computer forecast models. NOAA uses the data for its GFS synoptic scale model, as well as for its smaller scale model, the NAM model, and the European models, the Canadian models, all use upper air data collected by radiation balloons. We do have satellite observations that feed in a ton of the data that actually are initialized within a computer forecast model. And in the future, satellite observations are likely to replace these radiation observations. But for now, this is what we are dealing with. And when you take a look at a map of the U.S., first thing you notice is that these radiation sites, these upper air observation sites, are few and far between. For example, in the Mid-Atlantic region, you see a site right near Dulles Airport in Sterling, Virginia. There actually is another site not shown on this map, Wallops Island, Virginia, but very few sites over a given landmass, let's say the Mid-Atlantic region or the nation as a whole. Forecasters have begged for more frequent radiosonde launches and more a denser network of radiosonde sites, but it's always been rejected for the most part because of financial reasoning. But this is what we have to deal with, and this kind of data, even though it's few and far between, twice a day in stations that are many, many miles apart, it is critical, especially when it comes to longer range forecasts of snowfall amounts. Well, let's go through an example here from earlier this week. We're looking at the snowfall forecast map for the next 10 days, a 10-day period from the 12Z GFS model run. Now this has the most current radiosonde data, the most current upper air observation data fed into this particular model run. Again, a 12Z model run. Just kind of focus in on Virginia, for example, the DC metro region, right in this area right here. Notice very little, if any, snowfall in this particular part of Virginia. Again, from a 12Z model run. Now, let's take a look here at the 18Z model run. This is 6 hours later, and look at the big differences right here across Virginia, up to upwards of 9 inches of snow in some spots here, whereas the earlier model run, virtually zero, in most cases zero snow. So 6 hours later, the 18Z model run, which has stale upper air observation, 6-hour-old upper air observation, has the most current surface observations, but for upper air data, 500 millibars, 850 millibars, stale, 6 hours old, and it makes a big difference. It can make a big difference in snowfall amount, so you have to be wary. Let's go to the next 6-hour forecast map right here, back to the time period of 0Z that has the most current radiosonde data, most current observation data. And look, it's very similar to what we saw at 12Z. Little or no snow. Let's maybe an inch or two compared to the 12Z run. Let's go back. Here's the 12Z run again, focusing on Virginia. Then the 18Z run with a major snow event here in that 10-day forecast time period. And then back to very little, maybe an inch or two, 6 hours later. So be forewarned that if you love to take a look at computer-generated snowfall maps, especially over a long period of time, like 10 days out, you can go even out 15 days with these computer forecast models. Be particularly concerned if it's a 6Z or an 18Z model run. Wait for confirmation for the next model run at 12Z or 0Z, because those two particular times have the most current radiosonde data, where the 6Z and 18Z model runs have stale upper air observations, and that can make all the difference in the world in snowfall forecast maps. That's it for now. I'm meteorologist Paul Dorian.